We need to talk a little bit about light before we can get into electrons. How light interacts with atoms help to shape how scientists understood the atom. So light is a form of electromagnetic radiation. Light is energy. It is not matter. Remember, matter is something that has mass and occupies volume. Light does not occupy volume. Light is a kind of energy. It travels through space at a constant speed. We call it the speed of light. It's 3 times 10 to the 8 meters per second, which might not impress you, but 186,000 miles per second should impress you. Light can travel 186,000 miles in 1 second. Light has properties of both waves and particles. So waves. We can see waves in water. Here's a picture of water droplets falling onto the still surface of water. And as they fall, they form waves. And the waves radiate out from where they were formed. Right? You go to the ocean and you see the waves coming in and they crash. Right? We're familiar with waves. So the waves are created, and as those waves go out, they carry energy. As this water droplet is falling, it has energy. Its potential energy from being elevated above the surface of the water is converted to kinetic energy as it gets faster and faster falling. And when it hits the surface, it transmits that kinetic energy to the water down here. And that's what causes the wave, and the wave emanates. If you've been to the ocean and stood in the surf and had waves crash over you, do those waves have energy? Yeah, they do. They can knock you flat. They have a lot of energy. Okay? So energy is carried by waves. So here's how we quantify waves. So here's an illustration of a sine wave, and it has crests and it has troughs, and it travels in a direction. So the wavelength is the length of one wave. So from the crest, from one crest to the next crest, that distance is called the wavelength. You could measure it from here to the alternating node, or you can measure from trough to trough. It's all going to be the same. For visible light, the wavelength is what determines how our eyes and our brains identify the color of that light. Green light has a different wavelength than red light. White light, such as comes from an incandescent light bulb or from the sun, has all of the wavelengths in it. And if we pass a white light source through a slit and through a prism, we see it gets separated into a beautiful rainbow. The colors separate because their wavelengths are different. And how they interact in this prism is different because of those wavelengths. That's physics. When we see something that's red, here this woman's wearing a red shirt. We perceive this shirt as being red because the shirt is reflecting the red light and absorbing the other colors of light. So the sunlight hits the shirt. What bounces off and comes to our eyes is the red, and the other colors are absorbed. So if you see something that's blue, it's reflecting blue, and it's absorbing the other colors. Frequency. Frequency is another characteristic of light waves. This is the number of cycles or crests that pass through a stationary point in 1 second. So now you're going to see me draw very bad sine waves. Okay, there's one. I do better on the bigger ones. That one's pretty ugly. These are two different wavelengths of light. They're both traveling at the same speed. All electromagnetic radiation travels at the speed of light, 186,000 miles per second. So if these waves are traveling at the same speed, if you're a person standing here, help me, I'm being attacked by waves. Your person standing here and these waves are coming past, and both of these are traveling at the same speed, which one is going to pass more waves over you? The bottom one or the top one? The bottom one. This has a higher frequency. In a given amount of time, more crests of the wave are going to pass this given point where you're standing. So this is high frequency, and this is low frequency. Frequency and wavelength are inversely related. This has a long wavelength and a low frequency. This has a short wavelength, a low wavelength, and a high frequency. I think we'll leave it right there. We'll stay with light just being a wave.